As we are verifying trig identities, one thing we want to do is really only work with one side of the equation and try and get it to equal the other side. And it's often better to work with a more complicated side that gives you more things to do, and it's easier to make something more simple rather than trying to make it complicated. The other thing we want to do as we're going through this, we want to look for things that we can factor, maybe add fractions together or square a binomial, and always look to use those fundamental identities. Sometimes something that helps is to write things in terms of sine and cosine, and we can see what cancels out. As we go through these, one thing we want to do is keep our sheet of trig identities from last section nice and close that we can use, and we just want to keep on trying it as we go through this. Keep on looking for something to do. So for our first example, we have cosine squared theta plus sine squared of theta divided by cosine squared theta times secant squared theta is equal to 1. So obviously the more complicated side here would be the left side, and so that's the side we're going to manipulate and try and rearrange. And as far as verifying this identity, what we're really trying to do is make this side equal to 1. So as we do this, first thing I want you to always think of is anytime you see something like a cosine squared or a sine squared, is we should be thinking about those Pythagorean identities. And so we know that sine squared theta plus cosine squared of theta is equal to 1. So cosine squared theta plus sine squared of theta, we just said that is equal to 1. So that simplifies the top. So now we have cosine squared theta times secant squared theta, and we're saying that this is equal to 1. We're not going to change this side. We're going to leave it, and we're trying to manipulate this side to make it equal this. So as you go through these, here's the other piece that we want to look for is, what am I trying to do? Where am I trying to go? So begin with the end in mind as you do those. Now, one thing we know about these two is that they are reciprocals. So we know that cosine of x is equal to 1 over the secant, or secant is equal to 1 over cosine. So if those are reciprocals, then they are also equal to 1. So 1 over 1 equals 1, and that verifies that this is true. Our next example, we have 2 times the cosecant squared of beta is equal to 1 over 1 minus cosine beta plus 1 over 1 plus cosine beta. So again, I'm going to pick the more complicated side to work with, which is obviously the right side. And the first thing I would want to do here is add these fractions. I notice there's no fractions over here. It's all one term, so I'm going to combine these and see what happens. To be able to add fractions, remember we need a common denominator. So I'm going to be multiplying this side by our denominator here, 1 plus a cosine of beta, top and bottom. And I'm going to multiply this side by our denominator over here, which is 1 minus the cosine of beta, again, top and bottom. Now, as we go through and FOIL these, remember that ends up being the difference of squares, so that's going to turn into 1 minus cosine squared beta for our denominator. And now I have this quantity of 1 plus cosine of beta here plus our numerator here, 1 minus cosine beta. So we have a plus cosine and a minus cosine, so those cancel each other out, and so we have 2, 1 plus 1 is 2, all over 1 minus cosine squared beta. Now remember, we just said that anytime we see a cosine squared, we're going to be thinking about our Pythagorean identities. So I have here 1 minus cosine squared beta. If I subtract my cosine squared over to this side, I have 1 minus cosine squared beta, and that's equal to sine squared beta. So 1 minus cosine squared beta is equal to sine squared beta. Again, we know that if thinking about where we're trying to go, we're trying to say that this is equal to the cosecant squared beta, which we know that sine and cosecant are reciprocals. So we can rewrite this now as 2 times, remember you're thinking of that as sine squared beta, which is equal to cosecant squared beta. And we've now shown that these two sides are equal to one another.